Students, and after a long time we are meeting. So here we start with the new chapter, that is continuity. Now remember, first we shall see what do you mean by this continuity of a function. So it is a completely new chapter, that is continuity. Now you must have defined the functions. So how is a function defined? Y is equals to f of x. This continuity, the meaning of this continuity I shall show you first by the means of a diagram, that is the graph. Now consider the function y is equals to f of x. Any function y is equals to f of x. Suppose the graph of this function comes out to be in this manner. Any manner. Here we see that the graph from x equal to 0 to say some x is equals to a. If you look at the graph of this function, there happens to be no cut. In this graph. So this graph, this function we call it to be. So we are in the range closed interval from 0 to a. So this function we call it to be a continuous function. Suppose the graph from say some interval x is equals to a to some x is equals to b. If I draw the graph, it comes out to be like this. So here we see that there happens to be some cut in the graph. So this type of functions we call it to be discontinuous. This type of functions we call it to be discontinuous functions, and this type of functions we call it to be continuous functions. Now remember, these functions I have defined in a particular range, right? So from 0 to a, here we see that it is from 0 to a, and here we see that it's from closed interval a to b. Closed interval means what? The end points x equal to a as well as x equal to b is also considered. Now the examples of the continuous functions for all the real values. So if you can see, this is the graph of the sine function y is equals to sine x. So the sine function is continuous for all the values of x. Then the examples of discontinuous functions. This type of functions are called to be discontinuous functions. So for all the real numbers, because for some points in between 1 to 2 there is no value of y. Now mathematically, how to define this continuity of a function? Suppose, so definition of the function, continuous function I am going to give you. Suppose y is equals to f of x is a real valued function. Suppose y is equals to f of x is a real valued function in the closed interval a b. Remember, in the closed interval a b. Then you say that the function is, first I am going to define continuity of a function at a point, and I will be explaining you. Suppose y is equals to f of x is a real valued function in the closed interval a b, and x and c belongs to the closed interval a b is any point in between a and b. C belonging, so in between means it becomes to be open interval, and c belongs to the open interval a b such that limit of f of x as extends to c is equal to f of c. If this condition is satisfied, last year you have found out how to find the limit of f of x as extends to c. If this limit value is equal to the value of the function at the point x equal to c, then we say that the function is continuous at x equal to c, right? So this, if this condition is satisfied, that is limit of f of x as extends to c is equal to f of c, then how to define? Now we have defined it at any point. How to define it in the closed interval ab? So if the function is continuous at every point in the closed interval ab, if this condition holds good, because c is any arbitrary point, if this point holds good for every point in between a and b, then we say that the function is continuous in the interval ab. Then what we say? We say that the function is continuous in the closed interval ab. Now sometimes the function may be a straight function, polynomial function, or for the values less than c and for the values greater than c, the functions may be defined in a different way. In that case, if you want to find limit of f of x as extends to c, you need to apply the rule LHL is equals to RHL, both, and should be equal to f of c, that is the value of the function at x equal to c. So I am repeating this once again. Consider a function y is equals to f of x, a real valued function, in the closed interval ab, and let c belonging to open interval ab be any arbitrary point. If limit of f of x as extends to c is equal to f of c, then we say that the function is continuous at the point c, and if this holds good for all the points in the closed interval ab, if this holds good for all the point in the closed interval ab, then we say that the function is continuous in the closed interval ab. Yeah, one more condition sometimes we need to apply this, that is LHL is equal to RHL is equal to f of c, that is limit of f of x as extends to c minus is equal to limit of f of x as extends to c plus is equal to f of c, if this condition holds good. So the functions may be defined in different way for the values less than c and for the values greater than c in the range closed interval ab. In that case, if you solve some 2 to 3 examples, you will get to know. So in the next class, I shall repeat this once again for you, and we shall solve the problems based on continuity. Remember, continuity means there should not be any break in the graph. If there is a break, right, then we say that it is discontinuous, and if it is discontinuous, you need to show that it is discontinuous at the point x is equals to c here, right? Here in this graph, at this point, mathematically if you want to see, this condition will not hold good. Here you will be getting both the values different. In that case, you say that. So what is the mathematical definition of discontinuous? If the function is not continuous at the point x is equals to c, if the function is not continuous at the point x equal to c, then it is discontinuous at the point x equal to c. And if it is discontinuous at any point, if it is discontinuous at any point in the closed interval ab, then it will be discontinuous for the whole interval. So here we say that if you consider the whole interval, it is discontinuous. So these concepts repeatedly if you do, it will come for you all to understand. Thank you.